This is the Thames water barrier, the single most important flood defense system in the world. There are other barriers, but none come close to this machine's burden of protecting over 1 million people and billions in real estate. Its job is simple: stop a river from putting London underwater. Let's see how it works. Stretch a set of gates 520 meters across the River Thames to block it. Now, do it in just minutes as thousands of tons of water rush towards you. Then, when the threat's over, retract the gates quickly to let boat traffic through. And keep it working for decades without ever breaking down. The barrier was first used in 1983 to halt a storm surge from the North Sea. Surges that slam into the mouth of the Thames are a huge threat to London. Combine a storm with the river's high tides, and you've got a major disaster. Big parts of London would be swamped by floodwaters. So, to protect people and the city, engineers had to figure out how to block the Thames while maintaining its shipping channels. Their first big challenge was location. They chose a spot 15 kilometers from the Houses of Parliament, where the banks are straight and the riverbed sturdy enough for a massive concrete foundation. There are 10 gates in total that span the Thames. 6 sector gates that rise from the river. These include 4 large central gates and 2 outer ones. There are 4 smaller gates by the riverbanks that live above the water unless they're in use. All of the gates are hollow and made of steel. They fill with water when submerged and empty when rising from the river. Each of the 4 large gates is a hefty 3,300 tons, almost half the weight of the Eiffel Tower. The next challenge was how to get the gates out of the way quickly and safely. These radial arms drive the sector gates under the water to lie flat in concrete sills on the riverbed. This allows the free passage of river traffic. If forecasters spot a threatening storm, they notify the Port of London so that shipping in the area can be given the heads up. Red X's on the barrier tell ships to stay put. Operators in this tower control the movement of the gates. The closing sequence is designed to work with the natural flow of the river. After the outer gates are dropped, the sector gates are raised in pairs from the outside in. If the command center's computers were to crash mid-emergency, each pier has its own set of independent controls. And if they fail, the rams can be manually cranked. With millions of people and billions in property behind this barrier, nothing's left to chance. Even these radial arms are doubled up. Each one is powerful enough to move a gate on its own if the other arm breaks. They're powered by sets of hydraulic pistons. The top arm pulls in, while the bottom one pushes out. This rotates the sector gates up and into a defensive position. Operators normally close the barrier in about 90 minutes. In an extreme emergency, the entire thing can be set in place in just 15. But if you shut it all at once, the force of the entire river hits the barrier at the same time. And that could send a deadly rebound wave back downriver. If floodwaters ever threaten to top the gates, they're raised a little more to allow a controlled amount of water through. This is called an underspill position. It kind of acts like a dam controlling the levels of a reservoir. The closest any flood has come to topping the barrier is 2 meters. So far, so good. The entire operation is electric and has 3 independent sources of power. Electricity from the grid flows through cables in tunnels beneath the river. If the tunnels flood or power gets cut, there are 3 backup generators, each powerful enough to operate the entire barrier. The electrical bill for 1 turn of these screws? Almost 6,000 euros. On to the final challenge. The gates need constant maintenance to fight rust and water damage. How do you get that done without shutting down? By designing the whole thing for high and dry repairs. The gates come with an extra hydraulic piston to rotate them up and out of the water, so workers can repair damage and touch up the paint job. The gates do spend most of their time underwater, so paint is needed to fight rust. It takes about 40 tons of paint, figure 10,000 cans, just to cover 1 of the 4 large gates. Only time will tell how long this astounding work of engineering will hold up.